All right, we're gonna finish up those guided notes. We will continue a little bit past that, so you probably need a sheet of paper here in a second. We're still in the front, right?
Yeah.
Still in the front.
Yeah, you get a British accent.
I'm gonna go through this first one, even though we already did it. Just kind of walk through it again. Key thing here, it says find all solutions, correct? Before it was everything was contained from 0 to 360 or 0 to 2 pi. The directions do ask you to find them in radians and degrees. But when it says all solutions, we said there's an infinite number of solutions. Okay. Now we're not going to list them all individually, but we have to be able to represent them. All right, where does in degrees, for what values of what angles does x cosine square root of 2 over 2? So it's got to be a 45-degree reference angle. And since it's positive, it's got to be in quadrant 1 and quadrant 4. So it's going to be 45 and 315. But we said we got to list them all. And cosine is a periodic function, and it repeats every how many degrees? Every 360 degrees. So you can take 45, add 360, you get 405. Add 360, is that 765? Keep going, you can take 315, add 360, 675, add 360, what is that, 1,035? Now you can also subtract, so you can go both directions, okay? You can do negative and positive. All right, here's how we represent those. We say x equals, since I got two sets of answers, 45 degrees plus 360n. That repeats it every 360. And then you got 315 degrees plus 360n. All right, n just can't be any random number. There's one thing you just got to watch. N has to be what type of number? N has to be an integer, positive or negative whole number. Okay, and so I put for any integer n. For any integer n. All right, that's degrees. Radians, same thing. Except that's pi over 4 plus 2 pi n instead of 360, use 2 pi. And then 315 is 7 pi over 4 plus 2 pi n for any integer n. Okay, for that. Now that was for cosine. All right, tangent of x equals negative square root of 3. I want you to go ahead and take, if you need to use your calculator, you can. There's nothing against that at this point. You can figure it out just by walking through it, that's fine. This is one of the cases where you're not as familiar with tangent as sine and cosine, so you might want to just set up the two main cases because it's either going to be a 30 or 60 degree reference angle. So if the 30 is 1/2 over square root of 3 over 2, and the 60 is square root of 3 over 2, 1/2. Okay, which one is it going to be? Okay, because this right here is square root of 3 over 2 divided by 1/2. So square root of 3 over 2 times 2 over 1, square root of 3. So it's going to be a 60-degree reference angle, but it's a negative square root of 3. So my reference angle is 60. Where's tangent negative at? In quadrant 2 and quadrant 4. So that's 60 degrees, so that makes that 120 degrees. In quadrant 4, this is 60 degrees, so that makes that, what, 300? All right, now watch this. What is the period of tangent? It repeats every what? Gotta be careful here. What is the period of tangent? What is it? It's 180. The period of tangent and cotangent is 180. So take a look at this here before you start writing things down. Our first answer is 120. Add 180 to that, what do you get? Because you want to add period. What's 120 plus 180? 300. What's 300 plus 180? 480. What's 480 plus 180? 660. Okay, now what's my second angle that we had? It was 300. What's 300 plus 180? 480. What's 480 plus 180? What do you notice? It's going to be the same list of numbers, isn't it? Okay, so for tangent, I'm only going to have one answer. Okay, because the second answer is repeating the first one. For cosine, these are two different sets of numbers. 45, 405, 765, 315s. They don't overlap. They are two distinct sets of numbers. For tangent, since the period is 180, everything overlaps. I only need to put down one answer. So x equals 120 degrees plus 180 n for any integer n. Okay. Well, also write it in terms of radians. So 180 or 120 is 2 pi over 3. So 2 pi over 3 plus pi n for any integer n. For any integer n. Okay. So for tangent and cotangent, you only have one set of answers. Okay, put that down. So for tangent of theta and cotangent of theta, there will only be one set of answers. That's only when it asks for all solutions. If it just said from 0 to 360, you would list both 120 and 300. You would list both 2 pi over 3 and 5 pi over 3. Okay. All right, flip it over. All right, find all solutions. Now, what does it say? In the interval 0 to 2 pi, some radians of the equation 2 sine of x minus pi over 4 plus 1 equals 2. Okay. Now, it's just not sine of theta or sine of x. We got some things going on in here. I want to know the answers from 0 to 2 pi. You want to isolate the sine of whatever we're taking the angle of. Okay. So subtract 1. Two minus 1 is 2. Divide by 2. And I get sine of x minus pi over 4 equals 1 half. All right, I'm going to do substitution here. Some of you will kind of work around it and not have to do substitution. You can't. That's fine. But I like to do this just to kind of isolate things and make it a little bit easier. When I say substitution, I am going to let, if I have something other than just an x or a theta, I'm going to let, in this case, theta equal x minus pi over 4. Just makes life a little bit easier for me. And then I'm just going to say sine of theta equals 1 half. All right, so from 0 to 2 pi, what two angles have a sine of 1 half in radians? 30 degrees, which is pi over 6. And what's the other one? 150 degrees, which is 5 pi over 6. Now, on your test, you are allowed a calculator. Like if you just get there and you're just drawing a blank, you can plug that in. It'll give you 30 degrees. It won't give you the other answer. It'll give you one answer. You can at least do that. Now, I do need it in radians. So you're going to say, so I get two answers. So I got theta equals pi over 6. And I got theta equals 5 pi over 6. All right, that can't be my final answer because my final answer has to be in terms of x. Here's what you do now is you take out the theta and what do you put back in its place? X minus pi over 4. Some of you might just jump straight to this and do x minus pi over 4 equals pi over 6, and then x minus pi over 4 equals 5 pi over 6. I'm going to go through the substitution route, but like I said, some of you would just say, oh, yeah, I'll just make that equal pi over 6 and then 5 pi over 6. Make sure you add pi over 4. Let's see what you get. What is that? 2 over 12 and 3, 5 pi over 12. So 5 pi over 12. And add pi over 4. And what does that give me? What is that? 10 over 12, 3 over 12, 13 pi over 12? All right, so 13 pi over 12. So x equals 5 pi over 12 and 13 pi over 12. Okay. Isolate the sign of whatever you're taking.
So what's in parentheses actually doesn't matter. It's just on what's on the right.
Yeah, you're figuring, all right, what angle equals a half?
Okay.
Okay, it's the sign of what angle equals a half? And that's 30 degrees into 150. Okay, so that's a little bit why we do substitution. Okay, another sign. All right, let's take I'll set you up here on this one. I'm going to go ahead and do substitution right now. Okay, it doesn't matter if you do it now or later. If this is an x, I'm going to use theta. If this is a theta, I'm going to use x. But let theta equal x minus pi over 2. So 2 sine of theta plus square root of 3 equals 0. All right, go ahead and isolate the sine of theta and then just wait or think you're confident. Keep going, but I'll catch up to you here in a second. Okay, subtract 3, divide by 2. You're going to get sine of theta equals negative square root of 3 over 2. Sine is negative in quadrant 3 and in quadrant 4. Since it's square root of 3 over 2, reference angle 60 degrees. So that means that 180 plus 60 is 240. This is 300. But we are in radians. We are in radians. So I get theta equals 240 is 4 pi over 3. And then I get theta equals 5 pi over 3. What do I get up there? X minus pi over 2. Substitute that back in. So x minus pi over 2 equals 4 pi over 3. X minus pi over 2 equals 5 pi over 3. All right, go ahead. Add pi over 2. See what you get for your fraction. add pi over 2, common denominator is 6. So that's 8 pi over 6 plus 3 pi over 6, which is 11 pi over 6. And then when I add pi over 2 here, I get x equals, what is that, 10 pi over 6 plus 3 pi over 6, which is 13 pi over 6. All right, there's one thing you got to be careful here. It comes up every now and then. Your two answers for this will be pi over 6 and 11 pi over 6. Those are the two final answers. Why isn't 13 pi over 6 included there? It's not incorrect. It goes back to our original statement that your only answers are 0 to 2 pi. So 13 pi over 6 is too big. That doesn't mean there isn't a second answer. Where'd the pi over 6 come from? It's coterminal with that, so I just subtracted 2 pi to get that second answer. So it's in the interval. All right, so you got to watch it. It's going to come up every now and then. So you got 11 pi over 6. That's okay. It's less than 2 pi. This is out of that range. And so when they go to list the answers, they're not going to list them as 11 and 13. They're going to list them as 1 pi and 11 pi. All right, so just be careful there. The first answer, we were fine because 5 over 12 and 13 over 12, those are both less than 2. Okay, for that. All right. Now, just in general here. All right, we're going to go over a couple other things here that aren't on your guided notes. So you have a little bit of room there, but you're probably going to need something else. All right, in general, I need you to have kind of an understanding here. For different problems, you're either going to get 2 solutions, you can get 1 solution, or you can get no solutions from 0 to 2 pi. And just pay attention to this part. So I want you to think. So if sine of x equals 0.2, or sine of x equals negative 0.3, or if sine of x equals 0.8, how many solutions are we going to get? Or do you know? Okay. If sine of x equals any of those. Let me do this. What if sine of x equals 3, or sine of x equals negative 2.4? How many solutions are we going to get there? Okay. So if I do inverse sine of 3, I get error. If I do inverse sine of negative 2.4, I'm going to get an error. What's the condition there? What's the condition? It's bigger than 1 or less than 1. Now here's your sine graph. This kind of tells you the whole thing. Let me move this line here. Okay. This sine graph is your normal sine graph. What's the maximum it comes up to? 1. The minimum it comes down to? Negative 1. So if anything is above 1 or below negative 1, then you're not going to get an answer for the angle. For anything between 1 and negative 1, like 0.2, it's going to hit the graph twice. For 0.8, it's going to hit the graph twice. For negative anything, it's going to hit the graph twice. So it's going to have 2 solutions if that is between negative 1 and 1. Actually, don't put less than or equal to. Okay? So if that A value is between negative 1 and 1, you've got to have 2 answers. All right, there is a case where you'll get 1 solution. Actually, there's 2 cases. When A equals what? Logan? 1, because if you go all the way to the top, right there, it only hits it one time. But there's also another one, 1 or -1. Okay, so 1 or -1. And then it'll have no solutions if A is greater than 1 or A is less than -1. And that's going to be the same for cosine. Let me see something. Oops. And just pay attention here. For cosine, same deal. Once you get anything between 1 and -1 will be 2 solutions, but once you get to 1, or -1 and 1, you have 1, and anything above or below that'll be no solutions. But what about tangent? Tangent will have 2 solutions regardless because of how it's set from 0 to 2 pi. Tangent will have 2 solutions. All right. All right, let's get through at least one here. All right, copy this down. Let's get through this one. All right, don't foil it. Don't foil it. Stop if you are. Okay, because this is actually, you got to think about quadratics. Remember, if you have like x plus 2 times x minus 6 equals 0, you break this apart into x plus 2 equals 0, x minus 6 equals 0, right? So what do we do here? If it's already written like this and it equals 0, take each part and set equal to 0. Sine of x minus 1 equals 0. 2 cosine of x minus square root of 3 equals 0. Solve them independently. We're still from 0 to 2 pi. Sine of x equals 1. I'm going to do a couple steps here. Cosine of x equals positive square root of 3 over 2. All right, go through, think about those. Now again, I want you to do it without your calculator, but if it's not coming to you, go ahead and use your calculator, do inverse sine or inverse cosine. And you can type in square root of 3 over 2. I'm certainly hoping you remember. What angle has a sine of 1? The y-coordinate is a 1. That would be 90 degrees, which is pi over 2. So this is the one where there's only one answer. Square root of 3 over 2. Square root of 3 over 2. And it's a reference angle of 60. Nope, just kidding. Reference angle of 30. So it's pi over 6. And what's the other angle in quadrant 4? Okay, so it'll be like this. Here's 30. Square root of 3 over 2. That's 30, which is 330, but it's going to be what in radians? 11 pi over 6. And I'm just going to list my final answers in one set. Typically, you're going to be from lowest to highest. I'm not going to mark anything off if you just lump them all in there together, but normally you're going to see it as pi over 6, pi over 2, 11 pi over 6. All right. All right, going over those few things at the beginning, didn't get quite as far as I'm going to need to take a couple off. Not too bad. Just take off the last 2. So you got a 1, 2, 3, 4, 5, 6, 7, 8. Ross, I'm trying to get more 50% right. And then I think you got them all right. Oh.
I haven't touched my pillow on my house. Saturday.